I'm going to walk you through the compressor map. Right now we are working within GT Power software. This is a compressor section here, so where you can enter your parameters. Let me explain these parameters. Actually, we have main options, pressure ratio, plots, tabs. And here you can click here and put your data and compressor map. You can enter your compressor map here, okay? But what is this? If you have any question, you can click on help and see the objects. So, compressor map. This object takes compressor map data typically supplied by compressor manufacturer and creates a version of the map that is interpolated between the given data points and extrapolated to the pressure ratio of 1 and a speed of 0 RPM. So, a compressor map is actually, as you can see here, is one of the most important tools for understanding how a turbocharger works. It shows how much air the compressor can move, at what pressure, and how efficiently it does that. And it helps determine whether a turbo is suitable for an engine, where the turbo may surge, where it may choke, how efficient it is in different operating ranges, whether it is running too close to its speed limit. And why compressor map matters? Compressor map helps answer questions like, is this turbo too big or too small for the engine? And will it surge at low RPM? Will it choke at high RPM? It is operating in an efficient region, or is outlet temperature going to be too high? But let's go to the compressor map and explain axes of the compressor map, okay? So as you can see in this plot here, we have horizontal axis, okay, that is airflow, and pressure ratio, vertical axis. Actually, horizontal axis represents how much air the compressor is moving, okay, and about vertical axis, that isn't gauge pressure, okay, you can consider this. And you can see speed lines. The map usually has curved lines showing compressor speed, such as you can see 60,000, 80,000, 100,000 RPM, okay? These lines show how much airflow and pressure the compressor can produce at each speed. So, and about efficiency islands. In the middle of the map, you'll usually see closed loops called efficiency islands. They may be labeled, you can see 60%, 65, 64, yeah. But what they mean? The closer your operating point is to the center of a high efficiency island, the better. Less heat is added to the air, less energy is wasted, outlet air temperature stays lower, and overall turbo performance is better. So, okay, let me zoom this. You can see here we have surge line, red one, okay? is the surge is on the left side of the map here. But what is surge happens when the compressor is trying to create too much pressure for too little airflow. This causes unstable flow and air can momentarily reverse direction. And symptoms are fluttering or puffing sound, vibration, poor compressor stability, possible damage over time. In simple terms, too much pressure demand with too little airflow is called surge. And here we have choke line on right side. Is on the right side of the map. But what is choke? Choke happens when the compressor reaches its maximum airflow capacity. Even if speed increases, it cannot move much more air. And symptoms are airflow stops increasing significantly, efficiency drops, outlet temperature rises, compressor becomes less effective. So too much airflow demand is called choke. But ideal operating area, the best operating region is usually away from surge, away from choke, inside the higher efficiency island, not too close to the maximum speed lines. So in most cases, the middle area of the map is the sweet spot. In summary, how to read the map. Left side, low airflow, higher pressure, relative to flow, near surge, usually undesirable. Middle area, best efficiency, stable operation, preferred region. Right side, higher flow, approaching choke, efficiency can drop. And top right area, high pressure, higher flow, near a speed limit and choke, potentially stressful for the turbo. And at the end, what is the relationship between airflow and engine power? More airflow generally means more fuel can be burned, which means more potential power. So more airflow is equal more power potential, but only if the turbo is operating in a proper range. And why temperature matters? Compressing air raises its temperature. If compressor efficiency is low, outlet temperature goes up, air density goes down, intercooler load increases, knock risk increases in engines, okay? Gasoline engines.